Welcome to today's video. The first question that we will be looking at is question 4 from a March KZN 2023 exam paper. So we have question 4 that states, given f of x is equal to 2 over x and g of x is equal to x minus 1. So before we have a look at the questions, let's actually analyze the functions that we have been given. So we have f of x, which is equal to 2 over x. Now, because x is in a denominator position, we can see that this is a hyperbola. And we can see that g of x is equal to x minus 1, because the degree of this function is 1, because the highest exponent, or you could say the biggest exponent of x in this function is 1. We are dealing with a linear function. Always remember that if the biggest exponent of x within your function is 2, you are dealing with a parabolic function, or you could say a quadratic function. If you are dealing with a function whereby the biggest exponent of x is 1, you are dealing with a linear function. If your x is in a denominator position, you are dealing with a hyperbolic function. And if x is the exponent, you are dealing with an exponential function. So it is very important to be able to identify the type of function you are dealing with based on the equation or the graph. Now that we've discussed the functions, let us have a look at question 4.1. Determine the coordinates of the points where the two graphs intersect. So we know that if two functions intersect, they have the same x and y values at the points where they intersect. So all we need to do is equate the two functions. We need to make them equal to one another and then solve for x and y. So question 4.1, we will have f of x is equal to g of x. Now, from here, all we are going to do is substitute the equations of f and g, then solve for x. So we have 2 over x and x minus 1. From here, all we are going to do is cross multiply. So we can have x minus 1 over 1, and we can cross multiply. So 1 times 2 gives us 2, x times x minus 1. And all we need to do from this point is distribute the x into the bracket. That is going to give us 2 equals x squared minus x. From here, because we can see that the biggest exponent of x is 2, we know that this is a quadratic equation. So we are going to move everything to one side and make it equal to 0. So that gives us x squared minus x minus 2 equals 0. From here, we can factorize by using our completing of squares method. We can use our bracket technique, or we can even use our quadratic formula. Any method that works for you, proceed with that. I am going to factorize, and I know the factors of x squared are x and x. The factors of negative 2, when added, that give us negative 1, are negative 2 and positive 1. From here, we can solve for x as x is equal to 2 or x is equal to negative 1. Now that we've found the values of x where the two functions intersect one another, All we need to do from this point is substitute our values of x into the functions. It does not matter which. Whether you substitute it into f or g, you will get the same answer. So we need to substitute our values of x into the functions and find the y values. So if we substitute x is equal to 2 into f of x, so we have f of x equals 2 over x. If we substitute x as 2, it's going to be f of 2 equals 2 over 2. Therefore, f of 2 is equal to 1. So our y value when x is equal to 2 is 1. Now let's find the y value when x is equal to negative 1. So if we find f of negative 1, so we have 2 over negative 1, therefore f of negative 1 is equal to negative 2. Now let's go back to the question and read it once more. Question 4.1 states, determine the coordinates of the points where the two graphs intersect. So we need to find the coordinates. Always remember that whenever you write a coordinate, it is always the x value first, then the y value. So we can state that therefore our coordinates are 2 and 1, and negative 1 and negative 2. So those are our solutions to question 4.1. All we needed to do was find the coordinates where the two functions intersect one another. So if we were to draw a random rough sketch of the situation, we can have our function of f and then our function of g. So we can assume our points of intersection to be here. This is what it means when two functions intersect one another. It is when they cut each other. Now take note, this is a rough sketch. It's not drawn to scale, nor are the points accurate. It's just for you to get an idea of what's going on. So let us go back to the next question. Our next question is 4.2. On the same set of axes, draw the two functions, indicate the coordinates of the points of intersection on the two graphs. So now on the same set of axes, we need to draw these two functions. So let us start. We will start by drawing our x and y axis. Now that we've drawn our x and y axis, let us make a few notes regarding the important information that we will need in order to sketch our graphs. So we're going to start with the function f of x that is equal to 2 over x. Now, what is important to take note of regarding this function is that the value of a is positive. We have positive 2 in the numerator. That means our function is going to be in quadrant 1 and 3. If our numerator was negative, if our value of a was less than 0, it would have been in quadrant 2 and 4. Another important thing to take note of is that our function of f has two asymptotes, a horizontal asymptote and a vertical asymptote that is equal to 0. Now, we are going to sketch our function, but before we do that, keep in mind we made a note regarding the points of intersection. So we know that our function f has coordinates 2 and 1 and negative 1 and negative 2. So these are coordinates on our function. So we are going to plot these coordinates. The first one is at 2 and 1. So we make a dot by 2 and 1, that is over here. The next one is at negative 1 and negative 2. So that is over here. Now, all we are going to do from this point is sketch our function in the first and third quadrants. Now that we've drawn our function of f of x, we can now go and label it as f. So we can get rid of this information. It is no longer needed. Next, let us draw our function of g. So g of x is equal to x minus 1. We know that g passes through the coordinates 2 and 1, and -1 and -2. In addition to that, we can see that g has a y-intercept at -1. The constant is our y-intercept. So this is -1 over here. From here, all we are now going to do is make a straight line that passes through the 3 points. So that is our function g. We can put our arrows at the end to show that it continues, and we can label it as g. Now we can get rid of this information. Let us go back to the question and see if we have included all the necessary information. So the question stated, on the same set of axes, draw the two functions, indicate the coordinates of the points of intersection on the two graphs. So let us actually indicate these points of intersection. So this is -1 and -2, and this is 2 and 1. Those are our points of intersection. Now, let us move on to question 4.3. Question 4.3 states, use your graphs to determine the values of x for which 2 over x will be greater than x minus 1. Now take note, this is the same as stating f of x greater than g of x, which is the same as saying when is the red graph on top of the purple graph, or when is the red graph above the purple graph in the y-axis. So we have to find out which values of x will result in the red graph being above the purple graph. So if we go back to our graph, take note that the red graph is a hyperbolic function and it has an asymptote at x is equal to 0. That means we know for a fact that at x is equal to 0, the red function does not exist. Therefore, at x is equal to 0, it cannot be above or below or equal to the purple graph because it doesn't exist at that point. So to make life easy for ourselves, what we are going to do is we are going to separate this question into two parts. We'll have a look at to the left of 0 and to the right of 0. But we will not look at x is equal to 0 because the function doesn't exist there. So I'm going to start with the left of 0. I need to find out for what values of x will the red function be above the purple function. Now, whenever you deal with such questions that involve two functions, you need to locate the points of intersection. Once you locate the point of intersection, that is where you start. So we are going to start over here. This is our starting point. So we ask ourselves, if we go to the right of this point or to the left of this point, what is going to happen? But now I'm going to move this coordinate so that we can deal with this. Let's move it down here. So we need to identify if we go to the right, what happens, and if we go to the left, what happens. So let's try going to the right. So if we move to the right, do you see that the red function is now below the purple function? You can see that because the purple function is up here, whereas the red function is down here. So there's all of this space in between. So when you move to the right of that point of intersection, take note this is that x is equal to -1. So when you move to the right of it, the red function is below. Another way of thinking about this is if you were standing at this point and you were to walk on the red function, picture the red function as your road. So as you're walking to the right, to the right, to the right, do you see now if you look up, the purple function is above you. So as you're walking to the right, the purple function is above. We don't want that. We want the purple function to be below. The red function must be on top. So we now know that to the right of x is equal to 1 does not work for this question. So we bring our little man back to that point of intersection and we ask ourselves, what happens if we were to move to the left of that point? So if our little guy walks along this red road, do you see as he's moving further and further and further to the left, and if you were to look down, you can see that the purple function is below the red function. So if that is you and you are standing on that red road and you look down and you see this purple function down here, that is what you want. We need the area where the red function is above the purple function, where the red function is on top of the purple function. So we now know that that is true for all the values of x to the left of x is equal to 1, or rather -1. So from x is equal to -1 all the way to -infinity, that is when the red function will be above the purple one. Because you can see that the purple function is becoming lower and lower. It's continuously going down as you move to the left of -1. You can see the gap keeps on increasing. The space between the two functions increases. So we now know that the purple function is going lower and lower. So we now know that to the left of -1 is when f of x is greater than g of x. Or you could say when 2 over x is greater than x minus 1. Now, if we were to write this, there's two ways that we can do this. Number one is if you were to use an inequality sign, but you are not sure which inequality sign to use. Do you use this one, where the mouth opens to the right? Or do you use this one, where the mouth opens to the left? So all you need to do is draw an arrow in the direction that is true. In this particular case, the direction that is true is the left, because we know that the red function is above the purple function as you move further to the left. So our arrow points left. And if you were to copy the arrowhead, that is the inequality sign that you would use. So we are now going to answer question 4.3. When is f of x greater than g of x? Or when is 2 over x greater than x minus 1? Now that is at x less than -1. Let's go back and double check. Did they say greater than or equal to, or just greater than? It was just greater than. So we are now going to use x less than -1, meaning as you go to the left of -1. An alternative way of writing this is x an element from -infinity to -1. That is also an acceptable answer. Now, let us have a look at the right side of this function. To the right of x is equal to 0. So once again, we are going to identify our point of intersection. And it's that point over there when x is equal to 2. So once again, we can draw our little man, and we now need to walk. If we walk in the right direction, what happens? And if we walk in the left direction, what is going to happen? So let's start moving to the right. So if we walk to the right, and keep in mind our road is the red function. So we walk on the red function, and you see as you're walking, if you were to look up, you see that the purple function is above you. And you can see that as you keep walking, the distance gets larger. The height between, or you could say the distance between the red function and the purple function increases as you move to the right of that point x is equal to 2. That's not what we want. We don't want to look up and see the purple function. We want to look down and see the purple function. The purple function must be below. So that means we are not going to move to the right. So let's take our little guy back to that point of intersection. And now we are going to walk left. So we're going to walk up this little mountain or hill. As we walk up and up and up and up and up, you see that when you look down, the purple function is below you. So you can see that as you keep moving to the left, the distance between the purple function and the red function increases, whereby the red function is on top. If you look down, you see the purple function. The purple function is below the red function at that point. So we now know that to move to the left is the correct decision. However, we can't go beyond this point x is equal to 0 because that's an asymptote. The function does not exist at that asymptote. So we need to stop before we get to 0. So we can now state that our red function will be above the purple function from x is equal to 2. So we keep walking, x is equal to 2, all the way until x is equal to 0, but never touching 0. So between 0 and 2 is where the red function is above the purple function. You can even see it in the areas that I've highlighted. So let us answer this question. In state or, so it's between 0 and 2. And we don't use equal to signs because the question did not use equal to signs. In addition to that, the function does not exist at 0. So even if the question did use equal to signs, we could never use an equal to sign here where there's a 0. So the function can never be equal to 0. It can never exist at 0. The red function does not exist at 0. So this is our solution. So the red function is above the purple function for all the values less than -1 or between 0 and 2. Now let's have a look at our next question. So next we have question 4.4. If h of x is equal to 2 over x plus 3 minus 4, describe the transformation that takes f to h. So let's go and write this down quickly. So we know that if is equal to 2 over x. And we have this function h. So how did we go from f to h? If you want to go from f to h, you can see that we have to include this -4 and this +3 at the bottom. So what do these mean in terms of transformations? If you look at the -4, that is in a constant position. If you look at the negative, or rather at the +3, that is by the x, right? That should remind you of something. The general formula of a hyperbolic function. We know that q represents the vertical shift and p represents the horizontal shift. So in order for us to move from f to h, our function has to shift vertically and horizontally. So let's start here by -4. In order for the function to originally be 0, then to get to -4, we ask ourselves, how did this function shift to go from 0 to -4? If we go back to our graph, if you are at 0, so this is 0, and you want to get to -4, which we can say is over here, you have to shift 4 units down. So that is what happened to the function of f. It shifted 4 units down. So that's where we get our first mark. They 4 units down. Now we need to identify the shift that produced +3. We know that when you are shifting horizontally, a positive indicates a left shift and a negative indicates a right shift. So it's the opposite to a vertical shift. In a vertical shift, if it's positive, it will shift it up. If it's negative, it will shift it down. In a horizontal shift, if it is positive, it will shift it left and negative right. Actually make a note about that. That is quite important. So when you're talking about a horizontal shift and a vertical shift, remember that with a horizontal shift, positive is left, negative is right. With a vertical shift, positive is up and negative is down. That is why we have this -4 value that shows 4 units down. Now we need to identify the horizontal shift. We have +3. We know that when it's positive, it is a left shift. So 3 units left. So in order to go from F to H, we shift 4 units down and 3 units left. All you needed to do was was 0. So to go from 0 to -4, you shift 4 units down. To go from 0 to +3, you shift 3 units left. That is it. If we answer question 4.4, so that is our solution to question 4.4. In order for the graph to go from f of x to h of x, it was shifted 4 units down and 3 units left. There's some notes that you can go through later on. I will upload the PDF to the shared folder, and you can go through these notes a bit later as well. Next, we have question 5. The diagram shows the graph of a parabola f of x which intersects the x-axis at m and 0 and at 2 and 0. It is further given that 1 over 4 and n is the turning point of the parabola, while 0 and 6 and also k and 6 are the points on the curve of f. So we have all of these points, and m, n, and k are unknown. Now, an important thing to take note of is that this is an a less than 0 function. Has a sad face, therefore, with a negative parabolic function. So our first question, question 5.1, determine the value of k. So if we go back, let us identify what does k represent. So we can see that k represents some x value when y is 6. But if you notice, both of those have the same y value. They both have a y value of 6. And based on that, we know that the distance between this point and this point is the same as the distance between that point and this point. So basically, they have equal distances. You can assume this to be the midpoint. It would be the same if you draw another horizontal line. From here, let's call it A. To this point, let's call it B. To this point, let's call it C. The distance between A to B is the same distance between B to C. So now that we know that the distance between those points are the same, we can use our midpoint theorem to find k. Because like we've mentioned, this is the midpoint, right? And we already have that x value, 1 over 4. So all we now need to do is use our midpoint theorem. We can state that 6 is x1, k is x2, and 1 over 4 is the midpoint value of x. And this is question 5.1. So we have x midpoint is equal to x1 plus x2. Take note, this is not the only way you can do this. We will have a look at another option in a moment. So the midpoint is 1 over 4. And x1 is 0, and x2 is our value of k, all over 2. From here, k is equal to a half. And that is it. Now, let us go back and look at an alternative method. We know that this point is the midpoint of x is equal to 0 and x is equal to k. So we ask ourselves, to go from 0 to 1 over 4 is 1 over 4. The distance between 0 and 1 over 4 is 1 over 4. That means the distance to go from 1 over 4 to k is also 1 over 4. So we can just add them up, and that will give us 1 over 2. That's an alternative method that we can use. Now, our next question, 5.2, determine the value of m. M is the x-intercept of this function. We have one of the x-intercepts, which is 2. We just need to find the second one, which is m. Take note that m is on the negative side of the x-axis, so m is going to have a negative value. One option is to ask ourselves, because we already know that to go from m to 1 over 4 is the same distance to go from 1 over 4 to x is equal to 2. They are equal. So we can ask ourselves, what is the distance between 2 and 1 over 4? And subtract that from 1 over 4 to get to m. Alternatively, we can use our midpoint theorem once again, whereby 1 over 4 is the x value of our midpoint. We can state that 2 is x1 and x2 is m. So we just repeat the exact same thing that we did with k. So we have x of our midpoint is equal to x1 plus x2 all over 2. This comes from the formula m into x1 plus x2 all over 2, y1 plus y2 all over 2. So you've seen this quite often in analytical geometry. So all we are doing is making use of the x portion. So from here we can substitute. That is 1 over 4 equals 2 plus m all over 2. From here we have 1 over 2, because if you multiply 1 over 4 by 2, because we cross multiply, you get 1 over 2. Move 2 to the other side, you get negative 2 equals m. We can put that into our calculator, and we therefore have m as equal to negative 3 over 2. That is our value of m once you solve the equation. Alternatively, like we mentioned before, if we try to calculate the distance between 1 over 4 and 2, we can state 2 minus 1 over 4. Let's see, how much does that give me on my calculator? I get 1.75. So that means the distance between 1 over 4 and 2 is 1.75. That means the distance between 1 over 4 and m is the same thing. So in order for us to find the distance between 1 over 4 and 2, take the big value minus the small value. Or you could say the value on the right minus the value on the left. Now, if we apply that same logic, the value on the right minus the value on the left should give us the distance. All you can do is solve for m. So it'll be 1 over 4 minus 1.75, and we can move m to the other side. So 1 over 4 minus 1.75, that gives me negative 3 over 2, so the exact same value. All you needed to do was take 2, subtract 1 over 4, you get the distance in between. Take 1 over 4, subtract 1.75, which is the distance in between, and you can get m. Alternatively, you could have used your midpoint calculation. Now, let us look at the last question. That is 5.3, the value of n, and that is 5 marks. So if we need to find the value of n, that is the y value of your turning point, we already have the x-intercepts and we have a few points on the function. So we are now going to use our x-intercept form to calculate the equation of this function. So let us start. So we have question 5.3. Our x-intercept form is y equals a into x minus x1, x minus x2. Take note that x1 and x2 represent the x-intercepts of the function. Now, we already know that the x-intercepts are m and 2. We calculated m as negative 3 over 2. So that is what we are going to use. So we know that x1 is equal to negative 3 over 2, and x2 is equal to 2. We're now going to substitute those values. These are our x-intercepts. Now that we've substituted our x-intercepts, we substitute any point on the function. So let's look for a random point. We can substitute 0 and 6, or we could substitute k and 6. Any is fine, as long as it's some point on the function. So I'm going to go with 0 and 6. So we'll substitute the coordinate 0 and 6. So from here, y is 6, x is 0. And if we put everything that's inside of the bracket as is into our calculator, we end up with a value of negative 3. So we now know that 6 is equal to negative 3a. Take note that that negative 3 came from everything inside of the bracket. We can divide both sides by negative 3 and end up with a equals negative 2. Now that we found the value of a, we can substitute a, x1, and x2 back into the original function and simplify it, and that will give us our standard form. Once we've obtained our standard form, we can use our turning point calculations or turning point formula to find the value of y. So we have y equals a into x minus x1, x minus x2. And we substitute a as negative 2. We substitute x1 and we substitute x2. From here, we can simplify this into y is equal to negative 2 into x squared minus a half x minus 3. From here, we can distribute negative 2 into the bracket, and we get minus 2x squared plus x plus 6. Now that we found the equation of our parabolic function, we can go back to our graph. We know that our x value of our turning point is 1 over 4. So we can substitute 1 over 4 into this equation and find the y value. So keep in mind this function was f of x. So we are finding f of 1 over 4, which is negative 2 into 1 over 4 squared plus 1 over 4 plus 6. From here, f of 1 over 4 gives us 49 over 8. Instead of calling it f over 4, we can even just call it n. And that's it. That's the first method that we could use. This is one of your parabolic functions forms. So we have 3 forms. We have a standard form, which is this form over here, the one you're usually used to, ax squared plus bx plus c. We have a x-intercept form, which is the one I've used. And lastly, we have our turning point form. Take note that anytime you want to find the equation of a parabolic function, you can either use your x-intercept form or your turning point form. In order to use your x-intercept form, you need to have both x-intercepts and a random coordinate on the graph. If you want to use your y-intercept form, you need to have your turning point coordinates and a random point. Next, let us have a look at question 6. This is the last and final question that we will have a look at in this KZN March 2023 exam paper. So we have question 6 that states, the diagram shows the graph f of x is equal to a to the power x. So we can see that this is an exponential function because x is an exponent. Now, then states point B, which has coordinates 3 and 3 and 3 over 8, lies on f. So this point lies on the function f. From here it states, show that a is equal to 3 over 2. So we need to find this value of a. Take note that we have a y value and we have an x value. So if we were to substitute this y and x value, the only unknown would be a, and we can then solve for a. So that is the method that I am going to use. So this is question 6.1. We need to find the value of a. And we are given the function y equals a to the power x. And we have the coordinate 3 and 3 and 3 over 8. All we are going to do is substitute. Take note that this is the x value and this is the y value. So 3 and 3 over 8 equals a to the power 3. From here, if we want to isolate a, if we want to solve for a, we are going to cube root both sides in order to get rid of that exponent of 3. From here, we then have a is equal to 3 over 2. Once you cube root 3 and 3 over 8. So we've now solved the question. We have found the value of a. Let us now move on to question 6. Question 6.2 states, write down the domain of f. So if we look at this function, you can see that it touches all of the x values. So we now know that our domain is x an element of real numbers. Alternatively, you can state x an element from negative infinity to positive infinity. If you wanted to find the range, you would state that the range is y greater than 0. So the function doesn't go below the x-axis. It doesn't go into the negative y values. The function only exists in the positive y values. So we have question 6.3. Draw the graph of g, the reflection of f, in the line y equals x, showing all the intercepts with the axis and the coordinates of another point on the graph. So if we want to sketch the inverse of this function f, and we're going to call it g, take note that a function and its inverse is symmetrical about the line y equals x. So this is the line y equals x. If we want to sketch the inverse, all we're going to do is interchange the coordinates. So we have this coordinate of 3 as the x value and 3 and 3 over 8 as the y value. So all we're going to do is interchange that, or you could say swap the x and y, and that will be the coordinate on the function g. From there, we also know that the function of f has an asymptote at y equals 0. We've already discussed that. So if your asymptote is y equals 0, when you interchange it, when you inverse it, when you swap it, it becomes x equals 0. So that means that the function of g, or the inverse of f, has an asymptote at x is equal to 0. So it can't pass the y-axis. So if we do a rough sketch, the function would basically look like that. So let's go and sketch it properly. So step number 1, we are going to draw our x and y axis. And this is question 6.3. Now that we've drawn our x and y axis, let us start by making a note of our asymptote. We know that the function has an asymptote at x is equal to 0. So this is the line x is equal to 0. Our function is not going to pass that line. In addition to that, we have the coordinate 3 and 3 over 8 and 3. Now, we know that the coordinate 3 and 3 over 8 is between 3 and 4, and 3 is over here. So our point is going to be about here. Now from here, all we need to do is draw our curve take note that there were a few important points that we needed to mention. So let's actually go back to the question and identify what those points were. So the question stated, draw the graph of G, the reflection of F, in the line y equals x, showing all the intercepts with the axis. So we've not done that. We need to draw the x-intercept. There's no y-intercept because the y-axis is the asymptote of the function. Remember we stated that the function g has an asymptote at x is equal to 0. X is equal to 0 is the y-axis. So because the function never touches the y-axis, we cannot have a y-intercept. So we need to find the x-intercept and the coordinate of another point on the graph. We've already put in another point. That is this point over here of 3 and 3 over 8 and 3. Now we need the x-intercept. We need to find that value. So let's go back to the question. We don't have the graph of G, but we have the graph of F. If we find the y-intercept of F, that will be the x-intercept of G. Because remember, you inverse it, you swap it. So the x-intercept becomes the y-intercept, and vice versa. And the y-asymptote becomes the x-asymptote, and vice versa. So if we are looking for the x-asymptote of the inverse, we need the y-asymptote of the original. So here we have f of x is equal to 3 over 2 to the power x. If we are looking for y-intercept, which is this point over here, where the function cuts the y-axis, we know x must be 0. So it's f of x is equal to 3 over 2 raised to the power of 0, and that gives us a value of 1. Therefore, the x-intercept will be 1 and 0, because the y-intercept is 0 and 1, so you just swap it, and you get 1 and 0. So let us go and plot that point of 1 and 0. So this is the point of 1 and 0. So that is our function of g. Next, let us have a look at question 6.4. Write down the equation of g. Take note that g is the inverse of f. When we inverse a function, we follow 2 steps. Number 1 is to swap x and y. So wherever you see x, you put a y. Wherever you see y, you put an x. The next step is to solve for y. So because we are solving for an exponent, we need to make the bases the same so that we can drop them. However, in this particular case, we can't make the bases the same, so we use our log rule. Our log rule states log base number equals exponent. So we know the base is 3 over 2. We know the exponent is y. And that means that the number is x. All we now need to do is substitute into our log formula. So we have log of the base, which is 3 over 2, the number, which is x, and that is equal to the exponent, which is y. From here, in place of y, we can put g of x. So we know that g of x is equal to the log of 3 over 2x. And that is it. Next, let us have a look at question 6.5. Now, question 6.5 states, write down the values of x for which g of x will be less than 3. So if we go to our function, we need to identify which values of x will result in the function being less than 3 in the y-axis. So less than 3, take note, here's the y-axis. So for it to be less than 3, it has to be all of these values down here. So take note that g is less than 3. It is lower than that horizontal purple line that I've drawn between the values of x equals 0 and x equals 3 and 3 over 8. So our solution is going to be x is between 0 and 3 and 3 over 8. So g of x is less than 3 between 0 and 3 and 3 over 8. Take note that we can't use equal to because the question did not use equal to. And that is it. Alternatively, you could have used x an element from 0 to 3 and 3 over 8. That is also correct.